Hello everyone, I am Chutian. Recently I am conducting my research in Chinese Academy of Sciences Institute of Software. Today I am going to talk about my recent work, Douleur, creating pain sensation with chemical stimulant to enhance user experience in virtual reality. As we know, pain is a human instinct and plays an important role for safety. Though haptic feedback has been studied for several years as one of several haptic sensations, pain sensation was not widely used in virtual reality. Therefore, in order to fulfill the gap, we developed Douleur, a wearable haptic device that renders intensity adjustable pain sensations with chemical stimulant, capsaicin. The prototype of Douleur consists 6 parts. They are microneedling, microfluidic channel, reservoir, micropump, and peltier with its heat dissipation system. The application of microneedling forms microchannel on skin at first. Then, capsaicin solution, which is stored in the reservoir, is pumped out and flows into the microchannel, thus creates pain sensation. To investigate the ability of controlling temperature and the volume, we conducted 2 evaluations. The volume control evaluation indicates that Douleur is able to control the volume precisely. The temperature control evaluation showed that the temperature can also be controlled by Douleur. Therefore, we believe that Douleur can precisely deliver capsaicin solution to the skin and is able to maintain the skin temperature at a preset value. Here we conducted 2 studies to evaluate our prototype, Douleur. In the first study, we investigated how the intensity level and type of pain are influenced by different capsaicin concentration and temperature in time series. For the pain intensity level, with the change of capsaicin concentration and temperature, the intensity level of pain changes. The higher the temperature and capsaicin concentration, the higher the pain intensity level. For the type of pain, with the change of capsaicin concentration and temperature, the type of pain also changes. With the increase of temperature and capsaicin concentration, main type of pain changes from shooting to hot burning. In the second study, we investigated how immersion changes when combined with virtual reality scenario with the application of Douleur. We designed 3 scenes: dog biting scenario, corrosive liquid scenario, and spilled hot coffee scenario. In the first scenario, participants were required to play with the dog and were suddenly bitten by it. In the second scenario, participants were asked to take a bottle of corrosive liquid and carelessly knocked it over. In the third scenario, participants try to get a cup of coffee stands on the edge of a cabinet. Unfortunately, coffee spilled out. The results show that in scenario 1, the immersion level increases from 1.2 to 5.4. In scenario 2, the immersion level increases from 1 to 4.6. In scenario 3, the immersion level increases from 1.2 to 4.4. Though not in the same level, the immersion increases with the application of Douleur. Then here comes to the discussion section. Firstly, for safety issue and efficiency, how to replace the used microneedling should be considered. We should design a structure that permits rapid installation and dismantling of microneedling. For instance, we could design a slot where microneedling can be inserted into and removed from easily. The temperature control system is also worth redesigning. To improve the efficiency, we could utilize a smaller TEC plate with lower power requirement. We could also choose a heatsink with better thermal conductivity, or even redesign the whole heat dissipation system. And also, how to reduce the tightness of long-time wearing of Douleur also remains a problem. One solution could be reducing the working hours of the device, which requires less power and thus we could use less and lighter batteries. Besides, we should also pay attention to the habituation of pain, which may influence the pain feedback formed by Douleur. High concentration and repeated dose of capsaicin induces an analgesia after initial pain sensation. Therefore, when designing the experiment, the capsaicin concentration and interval between each test should be also considered. And for the limitations and future work, firstly, it takes time to remove the pain sensation. And in our study, we rinsed participants' skin and applied oleic acid, which takes 30 to 45 minutes to remove the induced pain sensation. A more rapid method should be developed to better control the induced pain sensation. And people's different pain sensitivity should be considered. Future work should focus on how to provide a tailored experience, which therefore requires a calibration process. And the other feedback can also be induced by chemicals, such as the temperature, like warm and cold, and also itching and so on. Therefore, it is possible to induce multi-channel feedback with the application of chemicals. So, how to make chemical-induced feedback controllable still remains an open question. And here, I will say thanks to all of my co-workers, and also thank you for listening to my work. I'm happy to take any questions.